Welcome back to Connect and Transform. In the most recent video, we created the short script that you see on the right-hand side of the screen that produces a digital rain effect similar to that seen in the movie The Matrix. And as part of that, we have a grid of symbols that are very subtle that is behind the rain. And I thought, wouldn't it be nice to be able to show the channel logo using those symbols and have that be behind the rain? So I wrote a short little script to accomplish that, and that's what we'll be going through today. I'll give you a quick overview of what it does, and then we'll start coding. On the left-hand side of the screen, you can see an example output of the channel logo. So what the script is going to do is it's going to load the image into a canvas element, and then it's going to use a function to analyze the image at each pixel. And it's going to get the data for the red, green, blue, and alpha channels. And if it is fully transparent, then we're not going to write a symbol there at all. And if it is at all opaque, then we will write a symbol, but we're going to change the opacity. And so what we're doing is we're just grabbing the red, blue, and green channel values. We are adding them all together and then dividing by the maximum possible value of those three being added so that we get a number from 0 to 1, and then we're just assigning that to the opacity. There are no special offsets, no special expressions, and the one example result is exactly what you see on the left-hand side of the screen. So let's begin. I'm going to start by just writing a new script. I could add to the end of this, but I think for clarity's sake, we'll just produce a new script. And in addition, I'm going to comment out this line, so we're not going to be calling the matrix rain function for now. So basically, I've disabled everything that we did in the last video, and I've created a brand new JavaScript tag, and we're going to write everything in there. So to start with, we're going to define some constants. So we're going to have an image width and an image height. And I could probably get these programmatically, but I wrote this in a few minutes, so I did what was easiest to accomplish the goal quickly. And then we're going to instantiate not necessarily a new canvas element, but we're going to do a new off-screen canvas. Not every browser supports this, but a lot of the modern ones do. So that's going to be a new off-screen canvas, and I got to make sure to spell this correctly. And we're going to pass in our image width and image height. And then we also want to grab the context of that canvas. Okay, so it's all fairly typical, almost boilerplate kind of code up to this point. The next thing we're going to do is we're going to create a new image. We're going to define the image's source. In this case, it is called logo.png, and it is in the same local folder as this file. And then as soon as the image is loaded, we're going to execute a function. And in that function, we're going to add the image to the canvas. So that's using the draw image function, and we're going to pass in image, and we're going to place it at an XY coordinate of 0 and 0. Okay, so once we've drawn the image to the canvas, now we're going to execute our custom function to create our text art. So we're going to call it create text art. And I don't think we're going to need to pass any parameters to it. So let's set up that function now. Okay, so now we have our function create text art, and we're going to start out by defining some constants in here. So we need to define to what precision we're going to be analyzing the image. So like, are we going to be analyzing the image on a 1x1 grid or a 10x10 or a 20x20 grid? So we're going to have a variable to track that value, and we're going to call it grid sampling size, and we will initialize it to let's initialize it to something huge, like 100. And so what that means is the channel logo in reality is about 1100 by 1100 pixels. So if we're only sampling every 100 pixels, that means we're only sampling on a grid that's about 11 by 11. And the chances of that producing an image that makes any sense to us is basically 0. So actually, let's change that. Let's do 50 by 50. So that's going to give us a grid of potentially maybe 22, 24, 25 values in both the X and Y axis. It could be enough to show us something that maybe resembles our image. So we'll start there, and then we'll lower this to make it more and more precise until we have something that looks more like the image on the left. So we're going to have that constant, and then we're also going to have, we need to grab the screen width and the screen height. So I'm just going to copy these lines from the previous script. Okay, so now we have a constant called screen width and screen height. And then we're going to want to have an X offset and a Y offset because the image in the canvas is at 0, 0. But we're going to want to draw the image in our matrix digital rain SVG. We're going to draw that image at something other than 0, 0. So we want to have some kind of offset. So our X offset is going to be some integer, and that value is going to be the total screen width minus the width of the image, and then we're going to take the remaining value. So once you subtract the width of the image from the width of the screen, whatever remains, we're going to divide that by 2. And then let's duplicate that line for the Y offset, changing screen width to screen height and image width to image height. Okay, so now we have our X and Y offset constants. So now we can get into actually doing our loops to investigate the pixel color values. I'm going to copy these 2 loops from our previous script. Okay, so for this, we're going to have an X and Y, and the X is going to go all the way up to the image width, and the Y will go all the way up to, but not including the image height. Okay, and then instead of adding 1, X is going to add our sampling, grid sampling size each time, and then same with y. Okay, so that's going to produce our sampling grid of pixels to investigate. So now we're going to say we need to get the pixel data. So we're going to say let pixel data equal, and then that's going to be context dot get image data. And that's going to take an x and a y and then a width and a height. So we're going to pass our x and our y variables, and we're just looking at, we just want to get back information on a 1x1 pixel. So that's, and then, so actually this here is not the pixel data, that's the image data. So then we need to say dot data to get the actual pixel data in one line. Okay, so now that we have our pixel data, we're going to say if. Now here, pixel data is an array where 0 is the red channel, 1 is the green channel, 2 is the blue channel, and 3 is the alpha channel. So we're going to say if pixel data index 3, the alpha channel, is not 0. In other words, if the pixel is not fully transparent, then we're going to do something. Okay, so in here, we're going to create a text element, and I'm thinking I'm going to just copy some of this text and modify it. Okay, so we're going to create something, let's call it BG art. And we're going to be appending it. Yeah, we can go ahead and append it to that same container. We don't need to modify that. Now, as for the text content, yes, we can go ahead and create this function, but we need to make sure that instead of referring to it as this, that we refer to matrix rain. And we're going to fill it with a value. So we're going to fill it with the value F5F. And that is the opposite of the green value 5F5. So basically we're just swapping the values between 5s and Fs. And that'll give us a nice purple because we'll have more red, less green, more blue. And then we got to look at our X and Ys. So that's going to be, it's still going to be parse int, but it's going to be X plus X offset, and then Y is going to be Y plus Y offset. And then we got to look at that. We're just going to copy this string here. We're not going to bother with having too many links between the new script and the old script. I think the only link we're going to have will be this call here to matrix rain. And that should do it. Oh, we're going to set the opacity. So let's duplicate that line, and then we're going to be setting the opacity value. And we're going to be setting it to some float. So it's going to be somewhere between 0 and 1. Okay, and then we're going to take, it's going to be basically the sum of the red, green, and blue channels, and then we're going to divide it by the sum of the maximum possible values. So that would be 255 plus 255 plus 255. And yes, I could have just put 765 or whatever it is, that constant there. But by putting 255 plus 255 plus 255, it's very obvious what this expression is doing. And then here, this is going to be pixel data index 0 plus pixel data index 1 plus pixel data index 2. So we'll go ahead and save that. And then we'll go back over here to the left and we'll refresh and see if we made any mistakes or missed anything. And so we see that the grid here is basically a 50 by 50 grid, and it doesn't have that many samples. So let's cut that in half, 25. And we'll refresh. It'll take a little bit longer. So now we have results on a 25 by 25 grid. Let's go to 15 and we'll refresh. Okay, so now we're getting somewhere where we can see more detail. Let's go to 10, refresh. Takes a little bit longer. Okay, now we're getting a lot more detail. And now we're also getting to the point where the size of each symbol is probably bigger than 10 by 10, or probably around that size. So even if I decrease this, let's say I decrease it to 5 by 5, now this might take 4 times as long to run, probably will. I'm thinking that the symbols will be so big compared to the 5 by 5 grid that it may not actually be any more clear than a 10 by 10. I stand corrected. It is actually more clear, but it does take significantly more time to load. So the last thing I'm going to do is we commented out this line here to run the digital rain function. So I'm going to uncomment that, save, refresh, and I know this is going to take quite a while with that 5 by 5 sampling grid, but I'm happy with how well it reproduces that image. So I kind of want to see that in the background. I'm sure it's not going to run very well. Because with a 5 by 5 going across an image that's 1100 by 1100, so roughly speaking, in purple, there's 200 by 200 symbols, potentially. There's not actually that many because there's some transparency, but there's a lot of purple symbols there, and that's really slowing things down because there's so much in the DOM. But I am curious if I change that to be like 12, let's say, and we keep the digital rain on, I'm curious how well it happens. Well, that's not too bad. I think it is still slowing it down a little bit, but it works. Anyway, I will comment that out one final time. I'm going to change that back to a 5 and refresh this so that we can just get one final look at the text art. ASCII art, although it's in an arbitrary font with an arbitrary character set. And there you have it. It worked better than I expected. Thank you for watching.